Welcome back to your MATLAB mentor, where MATLAB turns math into motion. Let's go smarter, not harder. Opening up a new episode today, we'll continue our talking about several topics. Please make sure that you have been watched all the previous episodes as they are all depend on each other. Before we start, a quick reminder. Please feel free to go back to MATLAB documentation as where most of the examples inspired from. It's a great source and reference to learn as in exams or like even practicals if you are in school or college, like it allowing you as an instructor might allow you to use MATLAB documentation. So it's kind you're learning from your own resource. Okay, so let's begin. So today we're gonna start our talking with TNV. TNV is very like important function. It's just type of T distribution and it's abbreviated from student inverse cumulative distribution function. So TNV, as I said, it's just inverse cumulative distribution function. So TNV has two best friends. Yes, it has two best friends. So it has P for the probability and it has D for degree of freedom. But why we care? Like why we care about this function? Why I care and I just put it today in one episode for you guys. Okay, so it's helping us in finding critical values and also many confidence intervals for means, hypothesis testing, simulation and modeling, and maybe educational and statistical analysis. For example, like if I want to find right now the 95 percentile of student T distribution, and let's say with 50 degree of freedom, how I can do that. And by the way, it's very important to, as like coder or programmer, to translate words into code. So as I said in the beginning, I said degree of freedom of 50. So let's create like variable 50. And then B was equal 0.95. So right now T equal TV or this function, which is T inverse cumulative distribution, and I will open a bracket and he gave me a recommendation for B, which is it's already ready, and then my degree of freedom. So I have everything I do need. I have all the elements of T inverse cumulative distribution. So right now if I press run, I have the value of T. So it's very hard to see things in numbers or just like by a result of T. But if you have a T and you have a question, like he asking you about probability or like more like we're gonna explain this later, but like ANOVA or something like that. So you get you the value of T that you can plug in another equation to find another like result that wants to. So okay, let's see more examples. So what if I want to compute this time the 99 percentile, but for T distribution from 1 to 6 degree of freedoms? Feel free to pause the video and try it by your own, but we'll jump right away to it. So our degree of freedom, as I said, is from 1 to 6. So how I can do that? It start now at 1 and 6, and this colon means like it's 1. It covers 1, 2, 3, 4, 5 till 6. So from 1 to 6 and everything in between. So this my degree of freedom. The second thing I have B2, which is equal 0.99. So right now I have both, so I'm totally ready. So let's create our function. So right now TNV, but this time is B2 and my degree of freedom. Let's see what we can get. So okay, I don't wanna this, let's suppress this by the semicolon and let's see the value of T2. Okay, so T2 I have 1, 2, 3, 4, 5, 6. I have 6 values, and this makes sense because I have 6 degree of freedom. So it just expect MATLAB does expect us to have value for the first degree of freedom with this probability and value of the second degree of freedom with this probability, same as the third degree of freedom and fourth and fifth and sixth. Okay, so yes, the more I can increase the degree of freedom, 100%, the result will be different, and the amount of results, the number of values, will also vary, depending on how many degree of freedom I do have. Okay, so let's now move forward. Now we're gonna move to another function called FNV. It's almost the same. It's type of F distributions, and it's inverse cumulative distribution function. This is abbreviated from FNV. I choose to get everything that are related to each other in the statistical perspective, so it's very helpful, like if you're taking math class or having like data or working in a company, that you're gonna use most of this, all of those like equation. And this, in this episode, I will be very big in telling you guys what's the important of every function, because this how we're gonna be engaged in like learning those functions. And when you know the importance of anything, you're gonna be more capable to learn it more with like more passion, more engagement and enthusiasm. So FNV, it's inverse cumulative distribution function, and as I said, why we do care about this function right now. Okay, it's help us in finding critical values in f-test, which is essential in function like ANOVA, and we're gonna explain ANOVA later today. And help us in also regression analysis. This is one of the analysis for statistics, used in hypothesis testing and like maybe finding the confidence intervals. Confidence intervals like measures or like tells you how your data is accurate, and like if you are taking math class, I think you're gonna understand me more. And finally, like statistical simulation and modeling. So if you are making simulation for your data or like using different form of modeling, for sure you're gonna use the FNV. Okay, so right now it does need three things. Okay, it does need probability value. Okay, and it will be given to you for the most cases, but we're gonna find it, or like we're gonna put a value for it for us now. And 2 degrees of freedom, degrees of freedom of numerator and degrees of freedom of denominator. So we have 2 instead of 1, and just like the difference between TINV and FNV. So let's see an example. So right now P equal line space. We explained this several times by now. 0.995 and 100%. Okay, so quick recap. It starts as 0.005, end at 0.995. There is 100 evenly spaced points between them. So 100 evenly spaced point between this number, the start point, and the end point, and this my line space. Okay, this is, as I said, 2 degrees of freedom, right? The first one, let's make it 8, and let's explain this to be the numerator. The second one, let's make it 9, and let's explain this to be the denominator. Those might be given, or you have to find them by yourself. So it depends on instructor type of question, depend on like the nature of your class. Okay, so this FNV has P, and as I said, 2 degrees of freedom, number of degree of freedom, right? So DF1, DF2. So both are having the blue shades, then like both are relevant or like matching, connecting to each other, then like I am good to go. Okay, but before doing this, let's clear the workspace. So clearing the workspace, because I don't wanna think like to overrun on each other. Like if I have to DF1, then like MATLAB will get like confused and error might happen. So right now, if I press run, so I got a column with 100 double as like the line space. As I said, it was 100 evenly spaced with the 2 degrees of freedom. Okay, this might not obvious, so I wanna plot this, I wanna show these numbers in a plot because it's gonna like give more representation for my like code. So let's plot this using the P and X, F. So P is my probability values and F is my F inverse cumulative. So right now I will make just the usual things about my like plot, like grid on X label, let's make it like P, Y label, F, NV. Let's make like something like title. We explain this in depth, like how we can make our plot polished, but for your guys' time right now, I'm just make this to help us like explain to us or like guide us through the graph, but this is not the goal today. Okay. Semicolon, semicolon, semicolon. So right now it gives me the plot. So now it gives me better representation. So from 0 to 0.9, okay, the plot is increasing. And then from just 0.9 to 1, it start taking a horizontal or start going through like equilibrium. Okay, and this is just from 0.9 to 1. So the behavior from 0 to 0.9 is just like increasing, we can say like exponentially little bit, but from 0.9 to 1 you start to take a sudden huge increase on the x-axis. On the y-axis the same thing, like it start increasing from 0 to 2, from PE when P is 0 to 0.1, but we can see from 0.9 to 1 it increased on the y-axis from 2 to 7. So that's why I'm saying like it's very hard to understand this just in front of you as numbers, but when you put this in front of the plot or like in front of figure in front of you, of course you're gonna be like different experience. Okay, let's move forward. We're gonna explain another function which is also relevant, which is F cumulative distribution function. Okay, so this pretty much is the same concept, but instead of P as the probability, you just need values of X, but it also need both, like both degrees of freedom of numerator and degrees of freedom of denominator. Okay, so also before we start, like why we care, why I choose this function, or what might this function help me for usages. It's almost the same usages, but FCDF, it's helpful in calculating the probabilities more. As I said before, hypothesis testing, this is the same, this common, but it also helping me in understanding like T and F distribution behavior, like in upper and lower tail analysis. This is kind of like statistical, and many application in ANOVA and regression line, and we're gonna explain ANOVA later today. So let's try to implement or execute this function. So first degree of freedom, df1, and as I said, let's clear both. So df1 will be now from 1 to 5. df2 will be from 6 to 10. And now the x values will be from 2, maybe like 6. Okay, let's now plot them. F, CDF. So the x values and then degrees of freedom 1, degrees of freedom 2. So if I press run, we can realize that I got like five values, and this came because degrees of freedom from 1 to 5 is the same difference as from 6 to 10. So both give me like 5. So MATLAB counts this as just 5 values. That's why I have 5 different numbers depend on the 5 combination of both degree of freedom of numerator and denominator give me these values. Right now I wanna show you guys some like function when is not a function, but like if we reverse all of those things, there is 2 conditions might happen. So let's first reverse all of them and let's see what we can get. So if I did 1 minus FCDF, which is completely the opposite way, and then 1 exponential division divided by x, and then instead of df1 df2 it's gonna be df2 first and then df1. So it's completely the reverse. So let's suppress this. Let's see f2. This is the values of f, the first f. So right now f2, I got the same variables, like right here if I want. It's the same numbers, same everything. So what happened, or why I doing this right now? So if I reverse everything, it might give me the same result. And I put this line today in today's content because in many exams, you might give you a probability of 5, okay, like 5 probability of 5% or 95%. And if you wrote like 5%, they're gonna give you positive sign, but if you put the 95%, they're gonna give you the same number but negative sign. And many conditions also, if you reverse everything, it's gonna be like evens out in the end and gonna give you the same result. So I just wanna like get like heads up for this because this might happen at many situations or many exams. Like many questions might having the same case when you like reverse everything, but in the end of the day gonna give you like the same result or same number, or maybe different signs. So it really depends on situation and on the question. Okay, moving forward today, we're gonna explain the ones that I did mention a lot, ANOVA 1. So what's ANOVA 1? What's it's abbreviated from? It's just one way analysis of variance. What's the difference between ANOVA 1 and ANOVA without 1? So ANOVA 1 is just one way analysis of variance. As I said, ANOVA without the 1 means one or more ways of analysis of variance. So again, as always, why we do care about ANOVA? So this time it does compare multiple group means, simplifies statistical testing like FCDF, FINV. All these functions that we did explain before, they are completely relevant to ANOVA. Also, it has like, it can visual data and interpretation and has a lot of application in real world studies like as engineering, economics. So ANOVA used also like for arguments, like when people do want to argue about whether like all population mean are equal or not. Maybe like arguing about the alternative and null hypothesis. So all of this, I can do all of this function just by using ANOVA. So let's see an example. So let's see y equal, start with mesh grid 1 to 5. So mesh grid is basically like we are using this function just for making the dimension constant about 2 like variables, but right now it just like as like brief explanation for mesh grid, it makes the length of y will be the number of rows and the length of x will be the number of columns. And right now, because it ends with 5, so I'm gonna expect the mesh grid to give me 5 multiplied by 5 matrix, which means like 5 rows with 5 columns, all has the same dimensions. But right now, gonna give me one variable because I specify just the y, not two variables. And right now, I'll make RNG, which is random number generator, and I will press this as default. So this for just reproducibility, and now we have to expect using rand functions. So random number generator default, it's always relevant with rand function, which is random number. So we're gonna use it in a different way. So let's create y1. y1 will pu. Right now we're gonna use the normal random number, and now 0, 1, 5, 5. What this means, what each position mean. So 0 means it's my mean parameter, 1, my standard deviation, 5 and 5, these are the sizes that I did the mesh grid about them, which will be like 100 mesh grid. And now y1, this is the value, the input variables that I will plug in ANOVA one function. And basically the norm rand is the normal random numbers. So that's why when we use this for reproducibility, it always followed or combined with using norm rand after. Okay, so let's see when we making p equal ANOVA 1 right now, y1. Let's see what we can get. Oh, okay, so there is an error in line 52. Yes, so there cannot be suppressing. Let's see what we can get. Okay, so ANOVA give me a table and like figure. So let's start explaining the table. So the SS means sum of squares, DF mean degree of freedom, MS mean square error, F is the ratio of mean square error, and P is the probability, and it's comparing to me with like F. So why we care? What's the point of this table? No, the point of this table is that you might want the degree of freedom to calculate another function, or maybe like having the mean square error to put it in another formula and get another result. So it's very all of them are connected. And also we did assume all the degree of freedom, like we assume the degree of freedom 1 equal 8 or 5. But this is not always the case, especially if you have the real world data. You want the degree of freedom to be authentic and real, not just like assuming them. And you can do this by using ANOVA. Same as like sum of squares, same as the probability. So it gives you a lot of elements that is super, super helpful and important when you want to calculate another function. Okay, so right now it's time for our mini assignment. So our mini assignment today, I want you guys to just apply what we took. So use MATLAB to calculate and plot critical values for students T and F distributions. Number 2, apply one way ANOVA to a small data set of your choice to determine whether the group means are significantly different or not. Last task, include the use of random data like norm rand as we did, but like try different number, try to be creative as possible, because like this is how you can actually, when you are trying and like get errors and whether it's right or wrong, this is how you can like learn. Okay, so try RNG, which is random number generator, default in your code to demonstrate reproducibility, repro spelling ability, and explain how these tools help model uncertainty and validate results. So by now, we have reached the end of our episode. Please make sure that you did right and tried everything by your own. Feel free to do the mini assignment and leave comments for any questions. Mini assignment is just like an example, a practice more of what we did. It's basically the same ideas, but you're trying to do it by yourself, which is one of the best ways you always can learn anything is by active recalling. So you got exposed to the content, but now by trying this content by yourself, this is when you are actually learning. So when you are watching the videos, this is the first exposure, but then when you are applying this by your own, this is how you can actually learn. So please feel free to leave any comments if there is any confusion. As always, programming is about practice, and practice makes permanent. Thank you all, and see you next episode.